Good morning, dear student. I am Rupak Shah from the Millennium School, South City, Lucknow. Today I will be giving you the lecture number 9 from the chapter Electricity. Before start the new content, we'll have a small recap of the previous lecture. As we have used the formula for calculating the resistance and resistivity. Recall the formula, R is equal to rho L upon A, and similarly you can use the formula for rho also, that is RA upon L. Dear student, please understand that these are the two separate formulas, either for calculating the resistance in terms of rho, and if you are calculating the specific resistivity or specific resistance in terms of R. So whatever you feel best, you can do it. We will be doing some numerical problems from resistivity in coming lectures, so these formulas are extremely useful for them. Since you are going to give the assessment nearly very soon, so prepare well for them and practice all the numericals which are done in the previous lectures. Today we will be taking a small topic, that is of difference between the resistance and resistivity. Please note down the topic: resistance on this side and resistivity on this side. The first difference of resistance and resistivity is that, definition wise, the property to oppose electric current is called resistance, and resistivity will be the resistance or will be equal to the resistance if the material has 1 meter length or 1 meter and having 1 meter area. It means it is the resistance of the material with unit length and unit area. This is the first difference, definition wise. Second, it depends upon length, area, nature of material and temperature. As Poonam ma'am has told in the June session that it is depending upon temperature also. It means resistance depends upon temperature directly. So two physical factors and two non-physical factors. And the two non-physical factors, one comes the nature of the material and second comes the temperature. So nature you can easily find: metal, non-metals, metalloids, and temperature. It has been told that if the temperature increases, the resistance also increases. So it means that resistance depends upon temperature also. But on the other hand, resistivity never depends upon length, never depends upon area, never depends upon the temperature. It depends only upon the nature of the material. It means all things are immaterialized for resistivity. Only the nature of material is determined by the resistivity. So resistivity is given the new name also, that's called specific resistance, because it specifies the material or specifies the nature of the material. Third difference, it is not considered as a constant term. Resistance is not considered as a constant of proportionality or a constant term, whereas your resistivity is overall a constant term or a constant of proportionality, considered as the constant term which never changes unless until we decide the nature of the material. It never changes with the length, it never changes with the area, it never changes with the nature of material, temperature of the substance. But it can change with the length also, it can change with the area also, it can change with the nature, it can change with the temperature also. So this is the three differences. Please go through this video 2 or 3 times so we'll understand what is the difference between the resistance and resistivity. So in totality we can say that resistance depends upon one more factor, that is called temperature also. So if the temperature increases, the resistance also increases. If the temperature decreases, the resistance also decreases. So dear student, we are now coming to some more numericals based on power, especially the formula P is equal to VI, P is equal to V square upon R, and P is equal to I square R, that we already defined and already we derived in the last lecture. We will be doing some numerical on heating effect as well by the formula H is equal to I square RT, and some numericals based on Ohm's law also, V is equal to IR, not circuit based but some other type of statement based. So we are coming to the first question, that is, if 400 joule of heat is produced each second in 4 ohm resistor or 4 ohm resistance, find PT. I am repeating the question. 400 joule of heat is produced each second in 4 ohm resistor. Find the PD. While doing the numerical, it suggested that always write the known and unknown quantity. So here unknown quantity that we need to find is potential difference, V is equal to question mark. What is given here? Heat energy 400 joule, time is given 1 second, and your resistance is given 4 ohm. Your resistance is given 4 ohm. So when we apply the formula, see what formula we are going to use. H is equal to I square RT. Formula used is H is equal to I square RT. So if you find the I square from it, we get H divided by RT. Please see, we find the I from this formula. I square is equal to H divided by RT. And if you put the formula of, put the value of H is 400, resistance is 4, and time is 1. So you cut 400 by 4. What is the value comes in this? If you remove the square, so you get under root 100, and if you replace the square root, you get 10. So your I comes 10 ampere. So I value is clear to you. But in this question, we need to find potential difference. So potential difference is equal to IR. I is 10 and R is 4. I already have just determined 10. And what is R? 4 ohm. So what's your total PD comes? 40 volt. So I think this numerical is clear to you. Please say it also for 2 or 3 times. See, do the steps of your own. You will understand how you to do all the questions. So we are coming to the question number 2 now. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat produced in 30 seconds. Try to read the question at least for 2 times. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat produced in 30 seconds. So what did I told? Always write the known quantity. R is given 20 ohm. What is the I is given? 5 ampere. What is the time given? 30 seconds. And what do we need to determine? Calculate the heat energy. So what formula we will be using? H is equal to I square RT. So dear student, please see what is I? 5 square. What is the R? 20. What's your time? 30. Calculating 5 square 25. 20, 30. So on multiplying all this thing, you get 15,000 joule, which can be also written as 15 kilojoule. It means 15,000 joule of heat energy is produced if particular things are given to you. Please see this formula, do it calculation of yourself, find it the steps and calculate what the answer comes. So it's recommended that always you solve the question along with me, and if you're not getting the time now, you can just see it first, and then whenever you do the next, you can take the copy and pencil with you and then solve it and find it how we are doing the formula, right? So we are coming to the next question now. This question is again a very important question. A electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power? These are the small numerical to find power, and already we told that there are 3 formulas, common formulas for power. Power is equal to VI, P is equal to VI, P is equal to V square upon R, and P is equal to I square R. You just find whatever things are given to you, convenient for you, you apply the formula similarly. Just like this, in this question, what is the voltage given? 220. What is the current given? 0.50. You can write 0.50. So that's up to you. 0.50. And what you have to determine? P. So now you can generalize the formula. If V and I is given, what formula can we use for P? Formula can be used, P is equal to VI. The formula is P is equal to VI. So we are coming to this formula. P is equal to VI. What is your P? 220. What's the I? 0.50. 0.5 means 1 by 2. So you can cancel it. So you get 110 watts or watt. So power, you have already got it. we are coming to the next question, dear student. This is a good question for calculating electrical energy, which is very common nowadays in the examination to be asked how to calculate the electrical energy. I am reading the question for you. You can also go through this question 2 or 3 times. A electric oven rated 500 watt operates 10 hours daily or per day. What is the cost of energy used to consume the electricity at the rate of rupees 3 per kilowatt hour or electrical unit for 30 days? It means the electric oven is there given whose power is 500 watt and it is working for 10 hours daily. So the formula has to be used is electrical energy equal to power multiplied by time. Please say it. Electric energy equal to power multiplied by time. Now I am doing the question. You just see the which is given to you. I am just written the known quantity. P is equal to 500 watt. Time is given in 10 hours. Always remember that you have to find it electrical energy in terms of kilowatt hour. So how I am doing it? You have to follow the steps. Electrical energy is equal to P into T. What is your P? 500. What's your time in hour? 10. So how much value we get? 5000. Since it is multiplied watt an hour, so it is watt hour, but we need to convert it into kilowatt hours. So what we'll do? To convert it, we have to divide it by 1000. So if you divide it by 1000, how much value we get? 5 kilowatt hour. Please follow this step. To convert kilowatt hour, this watt hour into kilowatt hour, we need to divide it by 1000, and we divide it by 1000, we get 5 kilowatt hour. This for one day. How much electrical energy you are consuming? 5 kilowatt hour. So for 30 days, multiply 30. So it becomes 150. I think it is clear. And since you are consuming it for 30 days, now you can understand cost. If you are getting it for 3 rupees, please follow, 3 rupees, then how much money you are getting? I am doing it again. 150 already you got, and you have to multiply it by 3 rupees. So how much you get money you get? 450 rupees. So just understand here that for one day 5 kilowatt hour, for 30 days 150, and the cost becomes, you have to multiply this kilowatt hour with 3. So if you multiply 150 with the 3, how much rupees you get? Rupees 450. Follow the step once again. We are just again taking it. Electrical energy equal to power into time. What is your power? 500. And what is your time? T, 10. So what it comes? 5000 watt hour. How you have converted into kilowatt hour? By dividing by 1000, you get 5 kilowatt hour. And for 30 days it has to be calculated. So 5 into 30, 150. So to find the cost, 150 multiplied by the cost of 1 kilowatt hour or 1 unit. So 150 has to be multiplied by 3. So whatever the cost comes is rupees 140. So I hope these steps are clear with everybody, and practice them at least 2 or 3 times. Calculate and follow the steps. You will not feel any problem in doing all these questions. So I think this is enough for today, and practice them well and ask any queries if you have. I already told you that you are free to ask any question to us. You can ask it telephonically, or you can send the question in the WhatsApp so that we can revert back to you. We will be all giving these videos in the Flip Learn now, so you're supposed to see them very carefully and just tell us if any queries there. So thank you so much. Have a nice day and stay safe.